Okay, for the rest of the chapter, we've already solved polynomial equations. Now we're going to be looking at polynomial inequalities. Given a polynomial function f of x, a polynomial inequality has the general form f of x is greater than 0, greater than or equal to 0, not equal to 0, less than or equal to 0. Any of these can be classified as inequalities. The inequality f of x is greater than 0 is true anytime f of x is positive. And that's what that means. F of x is greater than 0 means that f of x is a positive number. If the inequality f of x is less than 0 is true when f of x is a negative. Now think about where that happens. F of x is positive means that you are up here. F of x is negative means you are down here. So let's put above the x-axis. That's where f of x is positive. And let's put below the x-axis. That's where f of x is negative. Looking at a graph, and that's what I just did there. It says, look at the function here. Name all intervals where f of x is greater than 0. And again, what I just told you was that means where your function is positive. And what I'm going to do that in blue. Everywhere your function is positive, I'm going to draw a blue right here. And that's simply saying, where is your function above 0? And we're going to actually use x values to indicate that. So we're above 0 from negative infinity up to here, because my graph goes forever. We're above 0 from here to here, and we're above 0 from here on to positive infinity. So that'd be from everywhere from negative infinity up to, I believe that is negative 3. And also everywhere from negative 1 to 0, and also everywhere from 1 to a positive infinity. Now where is it negative? Let's do it in a different color. My function is negative everywhere my function is below the x-axis. And I have two intervals there where it's negative, and that would be everywhere from here to here on my x-axis is below it, and everywhere from here to here on my x-axis is below it. So that's going to be from negative 1, 2, 3, negative 3 to negative 1. Or everywhere from 0 up to positive 1. That's where my function is less than 0 or below the x-axis. And now we're actually going to be solving some of these, and you can always check it by what I just did. You can pull it up on Desmos, you can graph it, and you can simply see where is it above the x-axis or below. But here's your steps to solving a polynomial inequality. Step number 1, we're going to move all terms to one side of the inequality so that there's a 0 on the other side. Step number 2, we're going to factor completely like we have been doing with polynomials. We're going to find its zeros. Step number 3, we're going to plot the zeros on a number line. And let me explain why we're doing this. When you plot those zeros, when you're dealing with an inequality, or excuse me, when you're dealing with a polynomial, those zeros are where you go from above to below the x-axis. Or from below to above the x-axis. There is nowhere else that you can cross from above to below or below to above. So therefore, if we can find those, that's going to tell us where my inequality goes from above to below or below to above. When you plot these zeros on a number line, it's going to divide your number line into regions. We're going to choose test points in each region, in each interval. We're going to substitute those test points in the function to determine if it's positive or negative. And we're going to write our solution using interval notation. Here we go. Number 1. Step number 1, we're simply going to graph this. Not graph this, but we're going to factor this. X squared plus 5x minus 6. We're going to find the zeros of that. So we factor two sets of parentheses, x and x, adds, multiplies, positive 6, negative 1. Set it equal to 0 to find those zeros. You get x is negative 6 and x is positive 1. We're going to plot those points on a number line, and we're going to use appropriate closed or open circles. If it's greater than or less than, again, we're opening circles. If we're doing greater than or equal to or less than or equal to, go ahead and close your circle. So at negative 6, and at positive 1. This polynomial crosses the x-axis. So what we're going to do, that now divides my number line into intervals. We're now going to simply choose values in each interval, maybe this value, and I don't know, maybe this value. Choose any values in those intervals. And we're simply going to test to see, does it make this a true statement? If anything in that interval makes it a true statement, then that interval, everything is a solution in that interval. So let's try -7. Again, we're just testing it. So you have x squared plus 5x minus 6 is greater than 0. We're wanting to know, where is my function greater than 0? So let's plug in -7 to see if that makes it true. When you plug in -7, here's what you get. 49 minus 35 minus 6 is greater than 0. That's going to be 49 minus 35 is 14 minus 6. 8 is greater than 0. That is true. If it is a true statement, that means this is a solution, and it means that everything in this interval is going to be a solution. Check another interval. Let's check 0 now. Does it make it a true statement? Plug it in everywhere you have an x, so that's going to be 0 plus 0 minus 6 is greater than 0, which is -6 is greater than 0, which is a false statement. Since this is false, then everything in that interval will be again false. Then you can check your next number. We're going to try 4. If you plug in 4 to your inequality, you get 16 plus 20 minus 6 is greater than 0. That's going to be 36 minus 6, which is 30, is greater than 0, which is a true statement. So that means that's a solution, and it means everything in that interval will be a solution. Another way of thinking of this, x squared plus 5x plus 6, if you'll think about what that graph would look like, that graph is a parabola. It's an upward shaped parabola. It crosses here and it crosses here. Where is that graph? Again, greater than means above. Where is that graph above the x-axis? Over here and over here. This entire interval and this entire interval, which is the exact same answer you got down here. So therefore, my final answer is going to be all values from -infinity up to -6, or all values from 1 to infinity will solve this inequality. Number 2, we're going to factor to find our zeros. So we're going to have to use bottoms up here, or slip and slide. X squared minus x minus 30. 2 sets of parentheses, x and x, -6, +5. Divided by 2, which is what we moved. So that's going to be an x minus 3 and a 2x plus 5. So my zeros are 3 and -5 halves. So we plot that on our number line. So since it's less than, we are going to do an open circle. So we have an open circle at 3 and an open circle at -5 halves, which is -2.5. We simply test values from each region. We're going to plug in, I'm just going to pick some values. We'll plug in -6, 0 is always easy to plug in, and +6. I'm going to go ahead and do that for you. And here's what I got when I plugged them in. When I plugged in -6, I got 63 is less than 0, which is false. When I plugged in 0, I got -15 is less than 0, which is true. When I plugged in 6, I got 51 is less than 0, which is also false. So therefore, my solution will be all values here, because that's the values that gave me the true statement. So my answer is going to be all values from -5 halves up to 3. The next one. And now we're dealing with x to the 4th, so we're going to actually have 4 different possibilities for our zeros here. Let's factor using quadratic form. So that's going to be x squared and x squared. Let's see, that'll be a -25 and a -1. Both of those are difference of squares. Difference of squares factored into conjugates, x plus 5, x minus 5, x plus 1, and x minus 1. And we can actually still bring that inequality sign down. That's what we're trying to solve there. My zeros would be a -5, and since it's or equal to, now we're going to fill in our circle as we plot these points. -5 and +5. -1 and +1. So that divides it into actually 5 different regions, and we're going to test a value from each region. Let me just circle the ones that we can test. We'll test a -2, a 0 here. Always test 0. It's always the easiest one to test. So there's the one we're going to test, and I will test that for you. Here's what I get, which leaves us with a true statement here. 2,457 is greater than 0. 25 is greater than 0, and also 2,457 is greater than 0. So my solution lies with the -8 region, the 0 region, and the +8 region. So my answer will be all values from -infinity up to that -5, or all values from -1 to +1, or all values from 5 to infinity. Now this problem actually reminded me of another method that we can use for solving this. If it's an x to the fourth equation, and this you can actually see the symmetry here. This is an even function. If it's an x to the fourth equation and we know our general shapes, what this graph looks like, this is going to be a W graph, something like this. And it had 4 different intersection points. So we know that our graph, if it's going to look kind of like this and it's going to cross here, 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 and here, we're simply asked, where's your graph above the x-axis? And we already know. It's above it over here. It's above it right here, and it's above it right here, which actually corresponds with the regions without us even testing anything out. Okay, number 4. I believe this is factorable by grouping. So let's try a 4x squared. Let's pull it out. We're left with an x minus 7, and this is definitely factorable by grouping now. Pull out a -1, you're left with x minus 7 as well. Is less than or equal to 0. Let's factor out the x minus 7, and you have 4x squared minus 1. We'll take down the x minus 7, and this is now difference of squares, which factors into conjugates. 2x times itself gives you 4x squared. 1 times itself gives you -1, is less than or equal to 0. So we now have our zeros are located at 7, -1/2, and +1/2. Plot those on your number line here. Since it is less than or equal to, we are going to do a solid circle here. -1/2 and +1/2 would be here and here. So therefore, we're asked to find out which regions, where is our graph below the x-axis or below 0. So again, we're going to test different values from each region. We'll try out -2 here, 0 here, and +2 here, and 8 here. Let's plug those in and see what happens. And here are the results. You'd have a true statement when your x value is -2. You have a true statement when your x value is +2. So that would be this region would yield true statements. So my answers are here, and this region yields true statements. So therefore, my answer would be all things from -infinity up to this point is -1/2, or all points from +1/2, which was right here, up to 7. And since it was or equal to, I do include these values as well because they are shaded circles. And let's go back and make sure I did that on the last one because I don't think I did. I should have included -5 because it's a solid circle. I should have included both of these, and I should have included +5 as well. Again, there's another method for doing this. A positive x to the third, if you remember that leading coefficient, gives you a graph that's going to look something like this. Your zeros in this case were here, here, and here. If you'll put them in order, this was -1/2. This was a +1/2 here, and this was 7. So where, if this is your x-axis, where is your graph below the x-axis? And that would be over here. Let's do it in a different color. That'd be over here, and that it's below the x-axis from here to here, which is the exact same solutions that we found from -infinity up to -1/2, and from 1/2 over to 7. Number 5. Again, first step, we always have to get everything on the same side. So we have 3x to the third minus 11x squared minus 4x is less than 0. Again, if you'll remember what an x to the third, positive x to the third graph looks like, you can already tell what answers you're going to have. Let's factor out an x. You're left with 3x squared minus 11x minus 4 is less than 0. We're going to use slip and slide. That'd be x squared minus 11x minus 12, two sets of parentheses, x and x, a negative 12 and a positive 1. Divide by the 3 that you moved, and you now have two sets of parentheses and x minus 4, because that does divide, and 3x plus 1. So your zeros here are 0, 4, and negative 1/3. Let's plot those in our number line. Since we're doing less than here, it's going to be an open circle. 0, 4, and negative 1/3, which is actually right there next to 0. So let's use our shortcut to determine which one of these are going to be our solution regions. So here, let's put them in order. This would be negative 1/3. If this is my x-axis, this is 0, and this is 4. So where is your graph over here less than 0? That simply means where is your graph below the x-axis? It's over here below it, so from here to here, open circle, and it's also below it here, which would be from here to here. So it's below the x-axis without even testing. From here over to here, the first region, then it skips the second region, and it's below it from, and those points are really close, the third region, and it skips the fourth region. So therefore, your solution will be everything from negative infinity up to, that was negative 1/3, not including, union, and then everything from 0 to 4. That's going to be your solution. Number 6, and we'll do this one by testing the values. I'll do them both ways. Let's move everything to the same side. X to the fourth. When you add 4x to the third, there we go, becomes plus 4x to the third. We've got to subtract 10x squared, which gives you 1 minus 10, which is negative 9x squared, minus 36x is greater than or equal to 0. Let's see, this might be factorable by grouping. Let's try that out. Or we could actually factor an x out to begin with, and you're left with x to the third plus 4, x to the second, minus 9x. Hang on just a second. I think I lost. No, minus 36, that's right. Is greater than or equal to 0. Let's factor by grouping. Put you some brackets here. We're going to factor out an x squared. You're left with x plus 4. We're going to factor out a negative 9. You're left with x plus 4. So it is factorable by grouping. Factor out the x plus 4, and you're left with an x squared and a minus 9. So there is your new problem. This is difference of squares. Difference of squares factors into conjugates. So x plus 3 and an x minus 3. So therefore your zeros are 0, negative 4, negative 3, and positive 3. So this is going to be a closed circle since it's or equal to at 0, negative 4, negative 3, and positive 3. Now we've got to find some values to test. Let me do it in a different color here. We'll test negative 6. We'll test, now here we're going to have to test something weird. We'll test negative 3.5. We'll test negative 1, positive 1, and maybe positive 6. So let's do that and see which regions are going to work. So here are my results. You have a true statement here, 324 is greater than 0, so that's with all my negative 6 regions, so there are some answers. You have a true statement here at negative 1, so that means that all of these will be solutions. And you also have a true statement here at 6, so that means that all of these will also be solutions. So for my solutions will be from negative infinity up to this point at negative 4, and we are including it, or everywhere from negative 3, I believe is what that is, up to 0, or anything from 3 to infinity. So there's all the solutions to this inequality. Number 7. Okay, step number 1, let's find all of our zeros. I don't think this is as factorable by grouping. You can try it, but it's not going to be. So we've got to use our rational roots. So let's make a list of all those. And in order to factor this, we now have to find one of these that works, and then that'll break it down to quadratic when we can use other methods. So let's test some and see what works. Here you see your function evaluated at 1 would give you 0, so therefore 1 would be a 0, so that means x minus 1 is a factor. So let's rewrite our function then as x minus 1 times x squared minus 8x plus 16 is greater than 0. So let's keep factoring x minus 1, and then this is x minus 4 times x minus 4. And I'm glad I chose this one to use the graph on, because something different happens here. You have a 0 at 1, and you have a 0 at 4. You'll have only two zeros for this, but if you remember, the general shape should be something like this. So how can we get by with only having two zeros? We have a 0 at 1 and a 0 at 4. And here's the rule. Anytime something is a 0 with multiplicity, if it's an even multiplicity, that means it's not going to be crossing there, it's going to be touching there. So your graph's going to go up, cross at 1, come down, it's going to touch at 4, and then go back up. So it's going to look something like this. So therefore, where is your graph above 0? That simply means where's your graph above this x-axis when you graph it. It's above it from here over to here. So in this region, excuse me, yeah, that's right. And then it's above it again over here, because it comes down and it touches it there. So it's above it everywhere from, okay, what are these values? This is the value 1 and this is the value 4. Your function is above from 1 up to 4, not including 4 because it's touching at 4. And then it's above it again from 4 over to infinity. So that's what your answer is going to look like. And that's much simpler than plugging in and trying to find the point. So let's actually do that once again, because I think we've got the other method that we can plot them and plug them in and all that. So let's find our zeros first. And this is not going to be factored by grouping either. So let's find all the factors of 21 over all the factors of 2, all of our possible rational roots. And there you see a list of all those possible rational roots. Now let's go through our list and let's try to find one that works. So here we see that 1 was a solution, so therefore let's break this down into x minus 1 times the leftover, which was 2x squared minus 11x minus 21. And that again is less than or equal to 0. And we're going to have to use slip and slide to factor the rest of it. So we now have, after slip and slide, we're going to have this. So I can now identify my zeros, which are 1, -3/2, and 7. And you can graph those on a number line if you would like to, but let's do it like this. Here's my number line. I know that my graph, since it's a positive x to the third, it's going to down or up, down, up. It's going to look something like that. It's going to fall to the left and go up to the right. That might be not exactly what it looks like, but it's close enough to where we can get an idea for these. This is my first 0, which is located at -3/2. I'm simply putting them in order. This is my second one, which is located at 1. Then my third one will be located at 7. Now I simply have to identify where is your graph below the x-axis. Because again, y equals 0, that simply means where's the function equal to 0 is the x-axis, where is it below it? So my function is below it over here. So that would be from here to here. And we're doing closed circles here. So from -infinity up to that point. Then it's above it. Then from here to here, it's below it again. And that's it. Then it goes back above it. So my solution will be my function is below 0 from -infinity up to -3/2, or equal to includes it. And then from everywhere from 1 to 7, it's below it again. So therefore, there is my solution.